is Nitu Sharma, Assistant Professor from CSC Department. Today, I will be delivering session on DBMS. That is Database Management System. In this, we will be discussing about data models, DBMS architecture, and database languages. Before understanding the data models, let's understand what is the database management system. See, if I would divide this database management system, I will split into the parts, that is database management and system. So first of all, what is data, what is database, and what is database management system? So data is nothing but it is a information about any object. Related to any object, the information will be stored into the database, and this information will be stored into the database will be in a structured manner. That is the database, I should say the database is a data collection of data which is stored in the database in a structured manner. And the database management system is a software that allows to create, update and retrieval of the data in an organized manner. So it also provides the security of the database. So this is the structure of the database, where database allows to create, manipulate and access the data, where we are using SQL software that are there are different examples of SQL, MySQL, Oracle, Microsoft SQL Server and so on. Next is data model schemas. Data model is a collection of concepts that can be used to describe the structure of a database. Basically, data model provides the tools to create database structure. By this structure, we mean to say that it can be the data types, relationship and constant that should hold on the data. It also includes basic operations for specifying, retrieval, updating and creating the database. There are types of data models which are conceptual data model, logical data model and physical data model. Conceptual data model is a high level data model where it provides concepts that close to the way many users. It is also a entity based data model and object based data model. And logical data model is a representational data model of a database, where it defines the structure of the data and how different data elements are related. Next is physical data model. This is a low level data model where it provides concepts that describes the details of how data is stored in the computer, and also it means for the computer specialist, which is not for typical users. So there are different types of data models which are by representation. There are 5 types of data models: hierarchical model, network model, relational model, entity relational model and object oriented data model. First one is, let's see first one, hierarchical model. The hierarchical model is a type of database which organizes data into a tree like structure based on parent-child relationship, where each record is a node which holds the data and links to the subordinate. Each node holds the data and links to the subordinate nodes, and it establishes the relationship between the between one to many relation from parent to children. The root node is represented on the top and the starting point, and the branches extended forwarded downwards to the child nodes. Each child node has one parent but potentially extends to the multiple children. Next is network model. This model is the extension of hierarchical model. This model can be consist of multiple parent segments. These are the multiple parent segments. These segments are grouped as levels, but there exists a logical association between the segments belonging to any level. They exist one to many logical association between the segments. We called it graph, the logical association between the segments. This model replaces the hierarchical tree structure with a graph-like structure. Next is relational model. So relational model, it organizes the data into tables where it consisting of rows and columns. Rows and columns. The relational model represents how data is stored, manages, and in relational database where data is organized into tables and rows. Each row of a table represent an entity. This is the entity or record, and each column represents particular attribute of the entry. The relational model transforms conceptual designs from ER diagrams into implementable structure. So here we can see that this is a table where the table name is student, which store the information about the student, where the different columns are here, roll number, name, phone, and the rows are here, which called as tuples. The data stored in the row, which called as tuple, and this is a table relationship, and this a particular field is known as attribute. Next is entity relationship model. The entity relationship model is a conceptual model for designing a database. This model represents the logical structure of a database, including entities. These are the entities, and this is the relationship. These are the attributes of the table. So let's understand what is entity. Entity is an object which stored as a data such as student, course, or company, anything, and the attribute is the property that describes that describes an entity such as student ID, course name, or employee email. Next is relationship, a connection between the entities such as a student enrolls or a course. What is the enrollment and which course it is the student is going to access. These detail will be related to each other. That is that shows the relationship between the entities. Next is object-oriented data model. In object-oriented data model, data and the relationship are contained in a single structure. In this, real-world problems are represented as objects with different attributes. All objects have multiple relationship between them. All objects have multiple relationships. Basically, it is a combination of object-oriented programming and relational database model. Next, moving to the three schema architecture. So we have three schema architecture in the database database. First one is internal schema, conceptual schema, and external schema. So what is internal schema? As its name understood, internal schema describes the physical storage structure about the data. Next is internal schema used a physical data model. Next is conceptual schema. It describes the structure of the whole database, or we should say it is a blueprint of a database. It uses a conceptual or an implementation data model. External schema, it includes a number, users view. Basically, this is an interface for the users where it uses a conceptual or an implementation data model. This is the diagram of the three schema architecture where I have described here external view, which is an interface for the users, that is end users, and next is conceptual schema, and afterwards internal schema, which is about the wholesome database. And there is also the levels of the database data model: external level, conceptual level, and internal level. In conceptual level, this is in an external level. This is an external. In conceptual level, the external conceptual mapping will be implemented, and in this internal level, conceptual internal mapping will be shown. Next is database user. So we have classified database user in different categories. Those are application programmers, sophisticated user, specialized user, and naive users. So there, first is application programmers. So application programmers, they interact with the database through the DML queries. Next is sophisticated users. These users request in a database through query language. Next is specialized user. They write specialized database application. Basically, these are the they do not fit into the traditional data processing framework. Next is naive users. They invoke one of the permanent applications program. They are the permanent user. They interact with the database without knowing that what is the conceptual schema of the database. This is the example. People accessing database over the web, bank tellers and clerical staff. Next, DBMS language. So we are using we are using here two or more languages here. Here I have described two languages, that is DDL and DML. DDL is data definition language and DML is data manipulation language. As its name specifies, the DDL is where the database designs. It is used by the DBA and database designer to define conceptual schema of a database, where in SQL command there will be inserting the data, alter the data and drop the data command will be used. And next is data manipulation language. DML commands can be used as standalone language. It is a query language, or it can be embedded within a general purpose language. It is a low level language or procedural language. The changes in DDL will be permanent and the changes will be done in DML will not be permanent. This must be embedded in a programming language, so we can modify there or update. The next is DBA, that is database administrator. Basically, database administrator will perform the responsibilities which coordinates all the activities of the database system, which has a good understanding about the enterprise's information resources and needs, and their DBA has responsibilities including schema definition, what will be the design of the schema, what will be the structure of the storage structure of the database, and the schema and physical organization, how the physical schemas organization modification will be there, granting users authority to whom it has to give the access, to whom it has to issue the commands, acting as a listening with the user, and as well as it will monitor performance and responding to changes in requirements. Next is transaction manager. A transaction is a collection of operations that perform a single logical function in a database application. So basically, in transaction management, this manager will be the responsible that all the action should be performed in a smooth manner. Transaction management component ensures that the database remains in a consistent state despite failures. So whatever the action will be done there, that will be performed in a smooth manner, where example, power failures and operating system crashes and transaction failures. Next is concurrency control manager, controls the interaction among the concurrent transaction to ensure the consistency of the database. Basically, it follows the atomic property. A series of action will be done in transaction manager, that is atomicity, that is atomicity, and that followed the acid properties. Sorry, my mistake. Acid properties, atomicity and consistency, isolation and durability. Next is storage management. Storage management is a program module that provides the interface between the low-level data stored in the database and the application programs and queries submitted to the system. Basically, storage management is providing an interface between the database and the users. The storage manager is responsible to the following tasks: interaction with the file manager, which file needs to retrieve, which file needs to update, and which file needs to be the accessed by the users, efficient storing, in retrieving and updating of data. So there is the overall structure of the database management system, how the internally database is structured. So here on the top we have naive users, application programmers, sophisticated users, and DBA. That I have discussed. The naive users are the permanent users, application program which are interacting with the database through writing an application, and the sophisticated user, those are the analysts, and the DBA, those are the special users which who are giving the access to the system or who are issuing the commands to the system. Next is the naive users is an they are accessing application interface, and the application programming will be writing code and in an application, and this sophisticated user, those are analysts, are writing a query, are using the query tools, and the DBA is using the administrator tools to define the schema design. Next, we have a dotted line box here, which is a query processor. Their application programmer will write a program and move to the compiler, and application program object code will be made there, and the query evaluation engine will help to the execute the query. Sophisticated user which are using query tools and go to the DML queries, and compiler and organizer will organize the queries, and query evaluation engine will execute the query in a smooth manner. Next is DBA, which is using administration tool and uses the DDL interpreter. Next is the storage manager, where we have four components here: buffer manager, file manager, authorization and integrity manager, transaction manager. Buffer manager will store the data, what is the data will be stored there, and to whom it has to give the access. File manager, as we know, the data is stored into the table that will be distributed in the files, and which file needs to be retrieved, that will be done by the storage manager. Next is authorization and integrity manager, which has the authority, which will be grant the permission, and it will check. Storage management manager will be check the permission. Next is transaction manager, that I have discussed earlier, which follows the ACID properties, that will that is based on the action where all the task will be performed smoothly. The ACID properties are atomicity, consistency, isolation, and durability. Next is disk storage, where our physical data will be stored there. So at the last, we should know that why we use DBMS: to avoid redundancy, inconsistency. For multiple file formats will be there, to remove that we are using data redundancy in the database, and duplication the data redundancy is nothing but a multiple file formats, duplication of information in different files, that will be removed by the data that will be handled by the data redundancy. To avoid difficulty in accessing data, so instead of writing a new program to carry out each new task, we are using DBMS to deal with the data isolation. So multiple files and that will be followed up on the multiple files and formats. To deal with the integrity problems, integrity constants are that become the part of program code, and it is easy to add new constant or change existing ones. Next is application areas of DBMS. See, DBMS is widely used application. So it is used in banking, for all the transaction will go smooth, and airlines, reservation schedules, to maintain the database in the airlines, the DBMS will be used. University, for the registration process or for the grades, or to maintain the records about the faculty, students, about the university, and many more. Sales, for the customer details, for the product details, for the purchasing. So it is managing in the database managing in sales. And next is manufacturing, that is production, inventory, orders, supply chain, human resources, employee records, salaries, tax deduction. So database management is very much helpful in different applications area. Thank you.